So we're looking at the practice set 1, the chapter 5 test review. We're going to look at number 3 together. I'm going to walk you through this. There's going to be a problem like this on the test. This is not going to be like if you miss this problem entirely, it's not going to be the difference between an A or a B. It might be the difference between an A and an A minus. Okay, so this is the type of problem where you really got to pull a lot of information together. And because we haven't done anything like it before, we're actually going to go over it ahead of time. So here we go. What they tell us in number 3 is that cosine theta is 5/13. And cosecant theta is less than 0. We're going to use that information to find tangent to theta and sine of theta over 2. So I'm hoping this first part here jogs your memory from chapter 4. Do you remember doing like reference triangles and putting them in the right quadrants? So let's see if we can use this information here to figure out what quadrant our reference triangle is going to be in. So we're going to draw a reference triangle. I'll go ahead and set up my XY axis. And if we're drawing a reference triangle, we just need to know about sines or cosines or tangents or whatever, whether they're positive or negative. That's going to give us some clues. So when I look at this, I see cosine is positive, right? Because that's a positive 5/13. Agreed. And then cosecant, remind me, goes with what? It's the reciprocal of sine. And so if cosecant's less than 0, then sine must also be less than 0. If cosecant's negative, then sine's also negative. So sine is negative. So what quadrant are we talking about where cosine is positive and sine is negative? Quadrant 4? All right, so draw me a reference triangle in quadrant 4. And go ahead and mark that reference angle. And use that first equation, cosine theta equals 5/13. You should be able to label two sides of your triangle, 5 and 13, based off of that. You got it? Cosine's adjacent over hypotenuse, 5 and 13. Is this all flooding back? Fond memories of all this? Yeah. All right. What do you suppose we're going to do next? Yeah, we're probably going to want this other missing side here. So we could do Pythagorean theorem. Anybody recognize this is a Pythagorean triple? 5, 7, 13. Does that work? 25 plus 49, 13 squared is 169. No. It's 12. So if we needed to, we could set up a Pythagorean equation and solve for this, but it does end up being 12. Just making myself a note to use Pythagorean theorem if it didn't come out so nice. Feeling all right so far? All right, that's great. So we know that cosine is 5/13. We're going to be dealing with tangent and sine here, so I'm guessing it's going to be to our advantage to go ahead and figure out what sine of theta is and what tangent of theta is. And that should be fairly straightforward because we've got our triangle, we know what quadrant it's in. Is sine going to be positive or negative in that quadrant? We already decided negative, right? And sine is opposite over hypotenuse, so sine is negative 12/13. Go ahead and figure out what tangent is. Think about whether it's positive or negative in that quadrant. And then use SOHCAHTOA to find your fraction. I believe tangent's negative in that quadrant, all right. And tangent's opposite over adjacent, so 12/5. So far, a pretty fun review of chapter 4, right? Yeah, all right. Cool, well, now we're home free. Now we're home free. So let's start with tangent 2 theta. And get out your identity sheet. Make sure you got this in front of you as you're doing your review, because you're going to have this on your test also. We have an identity for tangent 2 theta, if I'm not mistaken. It is, I believe it's 2 tan theta over 1 minus tangent squared theta. Does that sound right? I'm just pulling that straight off my identity sheet. It is? Cool. Well, look at us go. All we need to do then is substitute tangent theta in there a couple places. What is tangent theta? We just figured it out. It's negative 12 over 5. And then simplify that and we're done. Let's see here. What do we got? Calculator will actually do this for us. If you all know how to use your calculator to do this, you can type this in and just do math frac and it'll simplify it for you. I'll do it the old-fashioned way though. 2 times 12 over 5. It's going to be negative 24 over 5. Down here we got 1 minus, that negative is going to go away when I square it. 12 squared is 144, 5 squared is 25. And then I would clear my fractions. I'd multiply by a fancy version of 1. My bigger denominator is 25, so I'll multiply by 25 over 25. And that's going to give me, let's see, 25 over 5 times 25. So 25, let's see here. 25 divided by 5 would be 5, and then 5 times 24 is 120. Sound right? I think so. 1 minus, oh, that's not 1. Got to distribute that 25. 25 times 1 is 25. 5 times 1 is 25. That's going to cancel. So negative 120 over 25 minus 144. I'm not trusting my mental math machines today. 119, thank you. Negative 119, so that is really close to 1, isn't it? A little bit bigger. So 120 over 119 for the win. I hope that's right. Just to show you, a calculator would do this whole thing for you. But you got to get parentheses in correctly. So you would need a set of parentheses here and a set of parentheses here. But I got to just type the whole thing in. 2 times negative 12 over 5. And that parenthesis and the parenthesis on the numerator divided by here. 1 minus parenthesis negative 12 over 5 squared. And that parenthesis, it's going to give me a decimal, and then I can go math frac 120 over 119. Questions? Okay. You ready for the really tricky fun part? This is going to be awesome. All right. Next up, we're going to do the other piece they want us to do is sine theta over 2. Any questions about this tangent before we go on? I mean, this is the key step here, right? We just write this down and then we use the values that we got up here. And then it's just a bunch of messing around with fractions from there. I'm totally okay on the test. If you want to just put this in your calculator and go straight to an answer, that's fine by me. Just make sure you're confident using your calculator. All right, here we go. Sine 2 theta, or no, sine theta over 2. So I'm looking at my sheet. And it says it's alpha over 2 on my sheet, but we'll just change those alphas to thetas. There's a plus and a minus, square root, 1 minus cosine alpha all over 2. Which is awesome. Oops, that's not an alpha, it's a theta. This should be pretty easy because we know what cosine theta is, right? I mean, they told us that in the problem. Cosine theta is 5 over 13. So we can plug 5 over 13 in here. The trickiest part of this is to figure out if it's positive or negative. So on these identities, the ones, and I'm not making you memorize these, but on these identities, it's one or the other. It's not both. Okay, so I need you to know when you see this plus or minus, you're gonna have to do a little thinking to figure out which one it is. All right, I'll help you out with this. All right. So you guys with me? This is the trickiest part of what we're gonna do today. And this is again, this is the piece of the problem that like I would say is gonna separate the A's from the A minuses. This is kind of like, this will be the trickiest thing that'll be on the test. This is straightforward. The tangent 2 theta was straightforward. It's the sine, it's the theta over 2's that are tricky. So think about where theta is on our unit circle. I'm going back to my unit circle. Remember, theta is somewhere in our quadrant 3, correct? Give me an upper and a lower bound for theta in degrees. What's this angle right here? In degrees. Let's do degrees. That's 270, right? And this would be 360 or 0. It's somewhere between 270 and 360. If it's in quadrant 4, it's got to be somewhere between 270 and 360. Agreed? All right, so I want you to think through this with me. Theta is somewhere between 270 and 360. So then where would theta over 2 be? Smallest theta could be as 270. What's the smallest that half of theta could be? It would be half of 270, right? Which is 135. And what's the biggest theta over 2 could be? Well, it's going to be half of 360, which is 180, right? What quadrant is theta over 2 in? If it's between 135 and 180, what quadrant is it in? That's in quadrant 2. Right? So is sine going to be positive or negative in quadrant 2? Sine is positive, and so my answer is going to be positive here. So I'm going to put some notes down here. This is how I figured that out. I knew that theta was somewhere between 270 and 360 because it's in quadrant 4. We already figured out that theta is in quadrant 4. Which means that theta over 2 has to be, well, it has to be between half of this and half of this. So it's got to be between 135 and 180. If you think about where 135 and 180 is, that's all in quadrant 2. It's actually in the last half of quadrant 2, but it doesn't matter. It's definitely going to fall in quadrant 2. Well, we're doing the sine of theta over 2. If theta over 2 is in quadrant 2, then it's got to be the positive version of this. All right, let's say you're doing this on the test and you forget all about that and you just make it negative or positive, or you got a 50-50 chance. And I'm only going to take a point off if you get the wrong one, right? So, all right, so let's finish it up. We know it's positive. We're just going to plug some numbers in. So this is the square root of 1 minus the cosine of theta all over 2, but I left out cosine theta because we know what it is. They told us in the problem. It's 5 over 13. And we don't like those fractions inside of fractions. So inside of the radical here, let's bust this up. Or you guys just want to use the calculator? Nah, let's use our brains. What would be a good fancy version of 1 to multiply by here to bust this fraction? It's the 13 I'm trying to get rid of. I think 13 over 13. Sound good to you? That's all inside the radicals still. So 13 times 1 is 13, minus 13 times that fraction is going to bust the fraction and just be a 5. 13 times 2 is 26. That's the square root of 13 minus 5 is 8 over 26. We can reduce that. That's 4 over 13. Ooh, I know the square root of 4. That's 2. 2 over root 13. And then rationalize that. That's 2 root 13 over 13. Fun. All righty. You're going to have a couple more of those you're going to tackle. Oh, by the way, before we go on with this next one, bless you. Let me show you how you can check your answers on a lot of these types of problems. We figured out that this was in quadrant 4, correct? So I am going to figure out what this angle is right here. I'm just going to call it alpha for right now. And I can do that using this right triangle. For example, I could do an inverse, what do you want to do? Tangent, inverse tangent, 13 over 5. Let's do an inverse tangent of, oh, sorry, 12 over 5 would be inverse tangent, right? And I'm going to do this in degree mode just because it's easier for me to see. So inverse tangent of 12 over 5. This reference angle is about 67.4 degrees. Agreed? That's the reference angle, though. That's not theta. How would I find theta using that 67.4 degrees? Subtract it from 360. Okay, so I could go 360 minus second answer. So that's theta. Yeah. So theta is about 292.6. Y'all remember how to stow that into whatever you want to stow it. I'm going to stow it into x. X is representing theta. All right, now check it out. I'm going to do the tangent of 2x. Tangent 2x. Calculator gave me that answer. The answer we got was what? 120 over 119. 120 divided by 119. Oh my gosh, that is the exact same decimal. That makes me feel good. Let's see if we did well on this last one. We were trying to do the sine of theta over 2, so I'm going to do the sine of x over 2. 0.55, so on and so forth. Let's type in the answer we got. We got 2 root 13 all over 13. Hey, nice. So you can check these things too, if you have time. All right, that's number 3. I want to look at 5, 6, and then I want to talk about the triangle problems. So any questions on 3? I want you to go back and when you go to actually do set 1, I want you to go back and do this all on your own. You've got it in your notes now, but I want you to go through, run through the problem from start to finish and use this as hints as you go along. All right, let's look at number 5. Let's look at 5 and then, yeah. So sine 2x equals -1/2. It's this 2 in here that's screwing everything up. If that was just an X, we'd know what to do, right? We pull out our wheel of fun and we'd start looking for angles that have a sine value of -1/2. But it's a 2X in there instead of an X. That's a bummer. So what are we going to do? Well, here's what I'm going to do. I'm going to use a little W substitution. We're going to let W equal 2X. So my new equation is sine W equals -1/2. All right, W is just an angle. All right, pull out your wheel of fun. I'm looking for angles that give me a sine value of -1/2. Sine's negative in the lower 2 quadrants. I'm looking down here. -1/2 here and here. Looks like 7 pi over 6, 11 pi over 6. Cool. 7 pi over 6. And 11 pi over 6. Plus 2 pi n. N is an integer, all right? All right, you guys with me so far? All right, let's cross out this W because what was W replacing? It was 2X. Now, if I wanted to solve for X, I could use this answer to solve for X. How would you get X by itself? Algebra 1 question, right? Divide everything by 2. So then X would equal 7 pi over 6 divided by 2. Do y'all know how to divide a fraction by 2? Yeah, double the denominator, right? You'd be multiplying by 1/2, right? So this would be 7 pi over 12. Are we okay with half of 7 pi over 6 being 7 pi over 12? Yes, 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 okay. We'd also have to divide this by 2, though. It would be plus pi n. And X could also be, what's half of 11 pi over 6? 11 pi over 12 plus, and then half of 2 pi n is just pi n. Now in number 5, look at the instructions. Did they ask you to give a general solution like this, or did they ask for all the solutions between 0 and 2 pi? Between 0 and 2 pi? Okay. So X is going to be, we're going to make a list here. Is 7 pi over 12 between 0 and 2 pi? Yep. How about 11 pi over 12? That fits, doesn't it? What if I added pi onto 7 pi over 12? What would that give me? 19 pi over 12? This is 12 pi over 12. Is 19 pi over 12 between 0 and 2 pi? It is. We're going to need to include that also. What if I added pi to 11 pi over 12? 23 pi over 12? And that's between 0 and 2 pi also. Man, so we ended up with 4. What if I added, so we added 1 pi. What if I added 2 pi? That's going to be too big, isn't it? That's going to push us over 2 pi. Same thing here. So we're not going to get any more. Well, what if I did -1 pi? If I did 7 pi over 12 minus pi? No, that's going to be negative, isn't it? So that gets us out of our range also. So there's actually 4 solutions to this. So I would like you guys to go ahead and tackle number 6 right now. Do the same thing we just did. Follow those same steps that we just did. I'm going to streamline a little bit. So this time it's sine 2x equals 1. And rather than do the W substitution, I'm just going to say 2x equals, and I'm going to go to my wheel of fun and look for sine values that give me 1. I think there's only one angle that gives us a sine of 1, isn't there? But in radians. Pi over 2, but plus 2 pi n. Solve that, get x by itself, and then give me a list of all the things that are going to work for us. We're only interested in the values between 0 and 2 pi. Yeah, good. We feeling okay about that? So you only have to worry about doing this when you're solving an equation that's got like a 2x in it inside of your sign. I want you to look at sets. Let's see here. Where else do I see a 2x? Look at set 3. You see some 2x's in this. I'm looking at the block where we're solving equations. I see some 2x's in there. Do you see some 2x's? So this has got a tangent 2x in it. Now this one's nice because it's already factored, isn't it? Cosine and then tan 2x minus 1. That's already factored and it's equal to 0. So you can just start by splitting that up into 2 equations and solving those 2 equations. For this one, you're going to have to, when you solve this equation, you're going to have to worry about that 2x piece. There's one other that has 2x in it, and it's number 48. And I would say in this one, I would probably use the identity for this one. I think we did a problem just like this in our homework. Since it's got both sines and cosines in it, I would probably use the identity. Sine 2x is 2 sine x cosine x, if I'm not mistaken. And then we factored a cosine out. So play around with those ones. We'll have a look at them. All right, I want to look over this with you guys. I haven't decided on this, and I'm going to ask you for your help in making this decision. I want to look at the area problems down at the bottom. So there's area problems on last year's test. I'm kind of modifying last year's test. I can pull them off and replace them with some more equations or some more evaluate type problems. We haven't done area, and I'm curious if you guys are okay with just keeping it on there. Let's look at a couple problems, and I want you guys to be the decision makers, okay? Do you have your sheets with you, the identity sheets? If you don't have that out, can you get that out and flip it over onto this side here? You've got two formulas for area. There's area of a triangle with signs, and there's an area of a triangle using Heron's formula. So I'm going to walk you through the last two problems on this, and then we're just going to take it to a vote and see what you guys think if you want to do some area problems on this. I personally think they're pretty straightforward, pretty cookie cutter. Let's look at number 17. Go ahead and draw the triangle in number 17. Draw the triangle, put the values in there. Notice that we've got values for two sides at an angle, the sides A and B and the angle C. So if you had to choose between one of these formulas up here, which one do you like? And I'm just talking about the major categories. Would you think we're going to do area of a triangle or Heron's formula? Heron's formula's got S's, and it's all little A's and B's and C's in it. And S is all little A's and B's and C's. Do we have all the little A's and B's and C's? We're missing our little C, aren't we? We've got little A and little B though, and big C. Hey, one of these has little A, little B, and big C in it. So let's just use this one. The area, it says right on our sheet here that area is equal to 1/2 AB sine C. So all we got to do is plug numbers into it. A is 13.5, B is 16, sine C is 115. And then we reach for our calculator, we type that in and write down our answer, and we're finished. That's it. That's plug and chug. If we're rounding to the nearest 10th, I'm coming up with 97.9. They didn't give us units, so units squared. Type in your calculator, make sure you're getting that same thing. If you're not, check to make sure you're in degree mode. What do you think? Should we have one of those on the test? I mean, it's going to look just like that. And it should be super easy. I can tell you that if I were going to put this on the test, I will make you a promise that I will either give you little a, little b, and big C, or little b, little c, and big A, or it'll fit right into one of these. You're not going to have to do any other work other than get the right number in the right spots. Do you guys want one of those? Can you guys show me a thumbs up or thumbs down if you want one of those on the test? Cool. I think that's pretty much unanimous. How about Heron's formula? Let's do one of these. Okay, this one is like twice as difficult as the last one. No, this sheet, I am going to make this same sheet will be the last sheet that's on your test. Now, it's not going to have any of your notes or anything on it, but it'll have the wheel on the back. It'll have all these formulas, including law of sines and law of cosines, right? And your area formulas. And it's the exact same as this. The reason I can't let you use your own is some people have made some extra notes on theirs. But it will be the exact same sheet. It'll just be fresh off the presses. So no, you don't have to memorize these, and none of this is going to be on our memorization thing on Thursday. All right, let's try a Heron's formula, and we'll do a thumbs up or down on this one. This is literally twice as hard because it has twice as many steps. I'm not even going to bother drawing the triangle for this one, okay? So step one with Heron's formula is to find S. S is equal to A plus B plus C all over 2. So look at 18. They gave you values for A and B and C. Go ahead and plug them into that formula and figure out what S is. 12 all over 2. There's no shame in using a calculator. You get 17.5. Yeah. Yeah. Okay, and then we got to do the A part of it. So the area is the square root of S times S minus A times S minus B times S minus C. So this one, we're going to have to write down a whole bunch of numbers, and then we're going to have to type them all in the calculator and make sure we get everything straight. But S is 17.5. S minus A, that's 17.5 minus, what was A again? 9. S minus B, that's 17.5 minus, what was B again? 12. And then S minus C, 17.5 minus, what was C again? 14. And then that goes into our calculator. We'd be very, very careful with our parentheses. Hit enter, we got our answer, we're done. And I want everybody to try typing this into your calculator because that is literally the most difficult part of this, is making sure you get your parentheses all in the right places. Should be coming up with about 53.5. Unless I type something in wrong.
The funny thing is that I typed in calculator, and so I did it a different way. I did it by solving for A and then doing the other.
Oh.
And then I got 8.5. And then I just did it by here on the way. Got a different one.
Oh.
And so I just forgot to put on 0.5.
Oh, okay.
Yeah.
So you did it a different way and you got the right answer and did it this way and made a small mistake. What do you guys think? You want one of these on there? Should I take off an equation and put one of these on? Yeah, thumbs up or down? Let's get a vote. This one I'm not so certain. I just need the area and show me some work. Yeah. Up high so I can see him. Up or down. If you don't vote, then you don't vote. Okay, I don't see any thumbs down. So, all right, we'll do one of these too. So there's not a whole lot of practice with these. You might go, and I can post some more practice. There's one of each on set 2. I didn't put any triangle set on stuff on set 3. I'm still on the fence on this. We'll definitely do one of these. We'll definitely do one of these. Some of you aren't seeming so confident with this. Okay. I'll let you know next class. Ask me on Thursday. I should have it written by then. Last thing I want to do is talk about, so on the test, when you do the triangles portion, I'm not going to tell you whether to use law of sines or law of cosines. You're going to have to make that decision. Okay, so I just want to talk through how you can do that. So can I get you guys, whatever you're going to be doing your work on for this, so whatever sheet or notebook you're going to be putting them in, can I get you all to take a moment and go ahead and sketch the triangles for 11 through 16? This is going to take you a minute. Okay, but you're going to need to do this eventually anyways. Go ahead and sketch the triangles for 11 through 16. and leave some space for each one of them so that you can do the actual work. But I just want to look at the sketches and talk about visually how to know just by looking at your picture whether you're going to do law of sines or law of cosines. Okay. So and while we're doing this, can we be consistent about how we draw our triangles? Let's do, how do we want to set it up? A at the top, B, C like this. Oh, did I already screw it up for you? Sorry. All right, everybody do it however you want. B's at the top. Split the A and the B. All right. So you want B at the top, A down here. All right. So what I'm asking you to do is this for each of these. 21, A is 86, B is 24, and we're finding A. I'm just going to circle A. That's all I want. Just sketch the triangle, put the values in them. Don't start setting anything up or anything like that. Just sketch them. And then we're going to come through and talk about whether to use law of sines or law of cosines for these. Yeah, I got those in the right place. Thank you. I was kind of looking at that, wondering, it's a tricky problem. Okay, that's less tricky. Thank you. B is down here. C is here. B is 32. I don't want you just copying what I got up here. In fact, we'll do that. I want you to practice drawing these triangles. All right, so I already made the mistake where I didn't get the A's and B's and C's in the right place. I'm going to be super careful about that moving forward. Oh, these are some of the worst triangles I've ever drawn. So the reason I wanted to do this is so far we've mostly practiced law of sines and law of cosines as two separate things, kind of in isolation of each other. We haven't practiced so much how to know when to use one and how to know when to use the other. So there's a couple ways to go about this. I'll tell you that my preferred way of thought is try to use law of sines for everything, and if you can't, go with law of cosines. That's kind of my way to do it. There's another way that you can look at it using like side, angle, 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 side, all that stuff from geometry, and that works as well. But I'll kind of show you my thought process on this, and it kind of relies on the fact that law of sines is sine of an angle over a side, correct? And this angle and this side, like so if it's sine A over A, those two things are across from each other, always. So it's really easy for me to spot law of sines problems, because if I've got information where I've got a side and an angle across from each other, then I'm probably going to end up using law of sines to do it. Okay, so for example, and 11 is probably one of the most tricky ones. But I'm solving for A and it's across from 86. Right there, that's a link that tells me I'm probably going to be using law of sines. As long as I can find another side and angle that I know both of them for to use for my other fraction. Now, I don't know what's across from 24, but I would posit that that would be pretty trivial to figure out, right? I've got two angles in that triangle. You know what an angle's in a triangle add up to, correct? So you could find this angle really quickly, and then you're all set and ready to go for law of sines. In fact, let's do that. What is what's 180 minus 86 minus 21? 94, 73? Is that right? That's 73. So my law of sines equation that I would start with here would be, let's see, the 86 is across from the A, and the 73 is across from the 24. And double check you got your angles inside of your sines, and your sides on the bottom. And you guys know how to solve that, cross multiply and solve. By the way, would we need to worry about ambiguous case for this problem? No, how can you tell? We're solving for a side. When you solve for a side, you never have to worry about ambiguous case. All right, look at number 12. We're trying to find angle A. Notice that angle A is across from 34, which I know. Oh my gosh, and look at this. We got 102 and 32 across from each other also. That's a lot of sines problems right there. Absolutely. Do you see how I'm spotting it? I'm looking for the side and angle pairs that are across from one another. How about 13? Oh, before we move on, number 12, do we need to worry about ambiguous case for this problem? So I would say we're going to have to consider it. It's probably not going to work out because this is probably too big to fit another version of it in there, but I think we should definitely consider it. So we do need to worry about ambiguous case anytime you're solving for an angle using law of sines, and we are doing that. So we would want to think about it. It's not going to be possible if this is an obtuse angle. If it's bigger than 90, I don't think there's any way the other one can fit into it. But just I'm in the habit of I'm always going to write it down. I'm always going to try that second angle. So I would consider ambiguous case for this one. I don't think it's going to work, but I would consider it. What about number 13? Can you set up law of sines here? We're solving for an angle. Do you have the side across from it? You got another pair of angles side across from each other? That's a law of sines problem. Ambiguous case going to come into play for this one? Yep, we're solving for an angle using law of sines. And there's a good chance that this is going to have two triangles. What about number 14? Law of sines? Oh yeah, look at this. 45 right across from that 125. That's going to be one of my fractions. B's right across from the 17. There's another fraction. Ambiguous case on this one? Probably better check it. We are solving for an angle. Probably not going to work, but we should try. Now look at number 15. I'm solving for A and I do have the 131 that's across from it, but am I going to be able to make another pair of a side and an angle out of what I got here? Could you guys pause for just a few minutes? Thanks. There's no way I can find this angle unless I know this angle, and I don't know either one of them. So there's no way I can get that second link. I have the 131 across from the A, but I'm not going to find that other angle side pair across from each other. So law of sines just is not going to work for this. We're going to go law of cosines on this. What about 16? Yeah, I can't do law of sines. This is the only pair that I have. So I'm going to be stuck with law of cosines for that. Do we ever have to worry about ambiguous case with law of cosines? No. All right. So your problems on your test are going to be in this format. I'm not going to give you the triangle. You're going to need to sketch your own triangle. And you're going to have to choose whether it's law of sines or law of cosines. So, all right. I want to give you guys the rest of the time. Does anybody have any burning questions about the tests? We didn't go over a lot of this stuff. I kind of went over the stuff that I felt that we had covered the least throughout the unit. The majority of the test is going to be more like the other stuff that we didn't cover today. Yeah. Yeah. They're not super easy to make up, so I'll just use one of these if that's okay. So we said 13 looks like it's probably going to work out as well. It's definitely ambiguous case. So let me get some scratch paper here so I got a little bit more room. So we're going to start by setting up our law of sines equation like we normally would. We'll fill in our sides and our angles. And just be careful. For me, the biggest, most common mistake is putting the side in here and the angle on the bottom. I've done that plenty of times that I now double check everything. So the angles go up here. The C is across from the 35. Angle goes up here. 23 is across from the 24. And we're looking to get that C by itself. I'd start by clearing my fractions. I multiply both sides by 35. And then how am I going to get that sine off of there? We'll do an inverse. So now we've got C by itself. This is going to go in our calculator, but just so I don't forget, there's going to be another angle aside from the one my calculator spits out. And it's going to be 180 minus whatever my calculator gave me. So just checking I am in degree mode. So we got 34.7 or 180 minus that, 145.3. But I don't want to leave both of those angles if they both can't work. So we got to check and make sure that we can actually use both of those angles in the triangle. So 34.7, the first one, if you get an answer, the first one will always work. The second one sometimes doesn't. Can I fit a 145-degree angle in here along with a 23 and still have room for a third angle? We can. Yeah, so we would keep both of these. Now, when you do number 12, chances are, actually, I don't think 12 gives you a triangle. 12 or 14, when you find the second angle, you're going to find that it's too big to actually fit into the triangle. All right. You guys got the time? Let me know what questions you have. I'm going to come around and check your homework. Just show me your law of cosines practice. And yeah, ask some questions. Let's